Today we'll be working on the following problem. Let f be a Lipschitz function from R to R. That is to say that the absolute value of f of x and minus f of y is less or equal than a constant times the absolute value of x minus 1. And E is a Lebesgue measurable subset of R. We want to show that the image set f of E is also Lebesgue measurable. So pause the video if you want to work on this by yourself. Okay, let's prove this. So here's the properties of a Lebesgue measurable set we want to use. Basically, we know that a set A is a measurable, Lebesgue measurable, right? If and only if A can be written in the union of, let's see, H union Z, where H is a F sigma set. F sigma meaning like the countable union of a closed sets, right? And the Lebesgue measure use M of Z equal to 0. So we want to show, we want to use this. Basically, let's say E, we know E is Lebesgue measurable, so it can be written as this format, where, you know, H is a countable union of E sub n, and then the measure of Z, Lebesgue measure of Z is 0, right? So we can rewrite this in the following format. This is the countable union of E sub n, a closed set. E sub n is closed, right, for any n. So this is actually this is right in this format. 1 E sub n, and then intersects, let's see, m from 1 to infinity minus m to m, the closed interval. And then this can be written as, so the union of n m, and then intersect this, right? The reason we're written in this format is we want to see this f of h is actually the union n on m, and then f of E and intersect, right? So now, why we're doing this? Why are we doing this? Because E sub n is closed, right? So this set E sub n intersect of the closed interval from m to m is closed and bounded, right? Because they bounded by the bounded by m. This hence in R, we know if a set is closed and bounded, it must be compact. Now f is clearly continuous, right? Lipschitz function is a continuous function. So the continuous function mapping a compact set to a compact set. So we know this image of the compact set is closed. So f of E sub n intersect this is closed for any n and m. So f of h is actually f sigma set, right? So all we need to do is like we want to show like you know, m f of z. Now all we have to show is that the Lebesgue measure of f of z equal to 0. Since this f of E is just f of h union f of z, right? So we know this is a set of f sigma. If we can show this has a Lebesgue measure 0, then f of E is a it can be a union of the f sigma set and with a set of Lebesgue measure 0, and then we use this, then we know f of E is Lebesgue measurable, right? So now all have so now let's see, because for all x is in the open interval, we have f of x minus f of a is not so equivalent and x minus a, right? And this is less or equivalent b minus a. And then we also have this less or equivalent L and x minus b is less or equivalent, right? Because the Lipschitz. So now what does it mean? Like f of x is actually in this two. If you break this absolute value, you have f of a minus L b minus a, and then f of a plus L b minus a. This open open interval intersect, right? So you can make a little basically make a little bigger. So because this is less or equivalent, so let's make it a little bigger. So definitely it's in the open interval. We want to make sure this is an open interval, right? So f of b minus 2 times L b minus a to f of b plus 2L b minus a, right? So this is inside of the interval. And then, which means if we map the open interval a to b, this will be a subset of the above, right? It's subset of this. Now we want to, okay, so we have this, a subset of this, right? So now, because since the interval, the Lebesgue measure of z is 0, so we can find what? We can find a open set G such that we can make the Lebesgue measure of G is less than epsilon over, let's say, 4L, right? Because the outer measure of Z is 0. But since G is open, we know in R, G can be written as the union of open interval like this. And then this all are disjoint. Bj is empty, right? So this is the structure of open set in R1. And now from here, we know this AG, now we let G sub I to be in this format. So f of A sub I minus 2L bi minus AI plus 2L bi minus this is one open interval. These two are the endpoints, and then intersects this bi minus 2l, bi minus ai, f of bi minus plus 2l, 2 times l, and bi minus ai. Right? So the g, we let g sub I to be this. Now we can see like this from the above, from this one, from the estimate of f mapped the open interval a to b. So the image set, this clearly g sub I contains f map this open interval, right? So we now let's say Q is the union of G sub I. So now this clearly is open. G is open. It's the union of open sets, right? So now this Q is contains we union of the image set of f maps the open interval a sub I to b sub I, right? So this clearly because of this. So Q is the union of this, and then contains the union of the image set, and this one is the f, the image set of this, right? The mapping to this. And then what is this? This is just because the union of this we assume to be G, so f of G. And the G contains Z, so this contains f of Z, right? So, but now the measure of Q, the bigger measure of Q is definitely less or equal than the sum of the bigger measure of each G sub I, right? And then this is less or equal than, and each because the GI is the intersection of this, so the two endpoint, and then if you calculate it's just the bigger measure is just the length, right? So the length is what 4L times this, right? And now we assume the, and this is just 4L times, that's what you're going to 4L times epsilon over 4L, which is epsilon, right? Because the measure of G is the sum of the length of each open interval, right? So combine this, like we already show, like we can find the open set Q which covers f of covers f of G, covers f of Z. So, and then the bigger measure is at the most epsilon, for any epsilon. So that's f of Z, the bigger measure equal to 0. So from what we said before, right? So we apply this again. That means the image set f of E is the bigger measurable. Yeah, that's it.